All right, Orange, we have a good one today. Martin Fowler's site dropped a case study from Bayer and Thoughtworks that is basically the blueprint for how to build agentic AI systems that actually work in production. And I mean actually work, not demo work, production work.
That's exactly what we love to dig into here. Too many agent demos look great in a Jupyter notebook and then fall apart when real users show up. So what's Bayer building?
It's called PRINCE, Preclinical Information Center. Bayer's a pharmaceutical giant, right? They've got decades of drug safety study reports locked away in PDFs, thousands of them, some scanned, some with messed up metadata from system migrations over the years. And researchers need to be able to ask questions like, were any of these specific clinical findings observed in study T123456-2, and get a straight answer.
So traditional search wasn't cutting it.
Oh, it was bad. Keyword-based Boolean search over siloed databases. You'd have to know exactly what terms to use across which system. And if the metadata was wrong, which it often was, you'd just miss stuff. The real gold was in the PDF text itself, not the database annotations.
So they built a RAG system. That's the obvious move in 2025-2026.
Right, but here's the thing. They didn't stop at throw PDFs in a vector store and hope for the best. Prince went through 3 evolution phases: search, ask, and do. Search was the unified gateway, get all silos into one searchable place. Ask added RAG so researchers could ask questions in natural language. But do, that's the phase we're still seeing most organizations struggle with. That's where multi-agent orchestration comes in.
Walk me through the do architecture.
Okay, so this is where it gets really good. They built this agentic workflow using LangGraph, and they have this concept they call context engineering versus harness engineering. Context engineering is about what each agent sees, shaping the information that flows between specialized steps. Harness engineering is all the scaffolding around the models: orchestration, retries, fallbacks, observability, human review.
They're naming the pattern, not just building the thing. That's how you create something reusable.
Exactly! And here's the key insight. They don't just dump everything into one giant prompt. Even with huge context windows now available, they keep context discipline. Different stages get different context. Planning context for their think and plan step, retrieval context for the researcher, evidence context for the reflection agent, synthesis context for the writer. Each agent sees exactly what it needs and nothing more.
So who are these agents?
3 main ones. The researcher agent gathers information. It can do RAG over unstructured PDFs and text to SQL for structured database queries. The reflection agent checks if the evidence is actually sufficient to answer the question. And the writer agent synthesizes the final answer with citations.
Wait, so the system checks its own homework?
Yes, and not just once. They have 3 reflection loops. Process reflection: is the workflow on the right track? Are we choosing the right tools? Data reflection: did we actually gather enough evidence? Draft reflection: is the output complete and well formatted? That's the kind of scaffolding most people skip, and it's exactly why their systems fall over at production scale.
And this is all running in pharma, where regulatory compliance matters. Mistakes aren't just embarrassing, they have real consequences.
Exactly. That's why they also have a clarify user intent step. Before the system does anything expensive, it asks clarifying questions to nail down the domain. Toxicology, pharmacology. It pinpoints the right tools up front. It's a fail-fast mechanism. Catch ambiguity early before you start burning LLM calls.
So this is a pattern. Don't let the agent run wild. Build gates, build checkpoints, build reflection loops.
And it gets even better for scale. As Prince added more scientific domains, the single researcher agent with a flat list of tools became unmanageable. So they're evolving into a hierarchy of domain-specific subagents. A toxicology subagent that owns its own RAG pipeline and SQL queries. A pharmacology subagent with its own toolset. The top-level researcher becomes a coordinator that routes queries to the right domain expert.
That's literally organizational design theory applied to AI architecture.
Yes, you don't have one person in a company who knows everything about every department. You have specialists. Same logic for agents. Each domain subagent has its own prompt instructions encoding how that domain's data model works, which tables are authoritative, how to interpret key concepts. It keeps responsibilities coherent and makes testing way easier.
What about the human side? How do researchers trust this system?
Trust is built through transparency. Every answer cites specific chunks and study IDs. The system shows its step-by-step reasoning. There's continuous monitoring with length views. And here's the discipline I love. They didn't optimize for cost first. They optimized for accuracy and reliability first, then optimized cost. That's the right order. You can't save money on a system nobody trusts.
So the takeaway for our audience, people building agentic systems in their own organizations, is what?
3 things. 1. Context discipline matters more than context window size. Don't dump everything in. Route the right information to the right agent. 2. Build harness engineering from day 1. Retries, fallbacks, state persistence, reflection loops. That's not optional. That's what makes a demo into a product. 3. Don't be afraid to split agents into hierarchies when your toolset grows past what one agent can manage cleanly.
And it all starts with a clear evolution. Search, ask, do. You don't need to build the multi-agent architecture on day 1.
Exactly. They started with search in early 2024, added RAG, then added agents. It took time. And that's the honest truth about production AI. It's iterative. Start simple, validate with real users, then layer on the complexity. Prince is a masterclass in how to do that right.
2 cartoon fruits just geeked out over pharmaceutical AI architecture for 8 minutes. I love this show.
That's what we do, building reliable agentic AI systems, one study report at a time. Thanks for joining us. New episode tomorrow at 7 a.m. Central. Subscribe if you want more of this.